Okay, so in example number 1, we have negative 5x to the 5th minus 2/3 x squared. So to do the derivative, you're just going to use the power rule. So you bring down the exponent, multiply it by the constant, and you get negative 25x to the 4th because we take a power away. And then minus 2/3 times 2, so negative 4/3 x. So number 3, we have f prime of x equals, multiply your constant and your exponent. So you get negative 6x squared. Here you have a negative times a negative. So you get a positive 25 halves x. Now you're subtracting one away, so it becomes negative 6. And then if you made it a positive exponent, you get negative 6x squared plus 25 over 2x to the 6th. It's not wrong, it's just that if it's multiple choice, they're going to definitely make it a positive exponent for your choices. Great, so y prime is hi ho, so it's ho d high. So when you do your ho d high, it becomes 2x to the 4th plus 4, and then your high is 0. So this all cancels out, but it's minus high, which is 5, and then the derivative of the denominator, which is 8x cubed, all over denominator squared. And then 5 times 8 gives you negative 40x cubed, all over 2x to the 4th plus 4 squared. Y equals 5x to the negative 5th. So your first derivative is dy dx. So it'd be negative 25x to the negative 6. Because the power rule says you bring your power down, multiply it, and then subtract 1 from your exponent. Not without doing the quotient rule. Yeah. And then your next, yeah, because like if you do it this way, it's so much easier. Because like the next derivative, yeah, you just take 25 times 6 and get 150. And then it's x to the negative 7. And then the next derivative would be 150 times 7. And now it's negative 1050 x to the negative 8. And then the fourth derivative and your final exactly is 8 times 1050. So 8,400 over, yes. So that's what I was saying before. Not all derivatives have an end. So this is considered rational because it's a fraction. So like linear polynomial type functions will have beginnings and ends, but rationals will not. It's either or. I just have a tendency to take my final answers and make them positive.